DLL sit side by side inside the GAC. And again, what is that GAC and how you do that, all that again we'll see in the following session. And there are two types of assemblies. One is a private, another one is a public shared assemblies. The private assemblies are the assemblies that you can actually refer them into your projects, and they are specific to your specific project. And when you're referring a given assembly, they don't have to be sitting anywhere, just like COM. If you know what is a COM, like component object model, which is fine. For those who don't know what is a COM, that's one of the very, very popular technology that Microsoft has brought into the industry a decade back or 2 decades back probably, and industry has heavily used the COM in their implementations. That's one of the only way, in other words, available to develop a distributable applications or distributable components in that given time period. So component object model, there are a couple of drawbacks now, and one of the drawback is that the version compatibility issues. Once you have a version release, releasing another version is another pain, and also using the respective COM components into a given application is strictly done via the Windows registry. That means you need to actually register the respective components, and only when the components can be referred into another program and can be made use of it. Although the code-wise it's a distributable component, but there are a couple of hurdles in the day-to-day maintenance-wise as well as consumption-wise, and reusability of the components is one of the key drawbacks. The COM suffered with a lot of criticism. And .NET actually, because it's completely again Microsoft standard, so which can be of course written in any language. So it has a couple of interfaces. We will cover COM in detail in the forthcoming session. Today I don't want to get into much of it. So the point here is when we compare the COM with respect to assemblies, the couple of differences. For private assemblies, you don't have to register that anywhere. It's just a DLL that's available out of box. You can just put it in a given folder within your project and just add a reference to it. Again, how to add a reference, I will show that down the line, don't worry. Add a reference to your project just the way we have added a reference, or we see the reference being added to system.dll. Same way we can add a reference to a third-party DLL and consume it. You don't have to do anything else. And for shared assemblies, definitely, because multiple users are going to share the same assembly, so there should be a common repository, just like a Windows registry, so that the different multiple applications can refer to the same assembly and make use of it. A simple example of that could be your printer utilities that are sitting in your machine, or it could be a Crystal reports engine that's going to run, and also it could be our data access components or ODBC components for .NET that you want to make use in common for multiple applications on a given server. So in that course of scenarios, those DLLs or those assemblies need to sit in a common repository, and that repository is called a GAC, which stands for Global Assembly Cache. So for those to sit inside a Global Assembly Cache, those are called the public assemblies. Okay, and a private assembly, again, that's what this text is talking about. And for private assemblies, they are again deployed and use it directly. That's what it's talking about. When the component is removed, no registry cleanup is needed, unlike the COM components, and uninstallation and nothing is required. For private assemblies, you just have to delete that, it's gone. And in case of a shared assemblies, it need to get into the GAC. So that's all this slide is talking about. And of course, namespace versus assembly, and we haven't seen what is a namespace so far, right? What is a namespace? Okay, the namespace, in simple, if you want to visualize a namespace as just like your folder structure. I just quickly open the folder. The only best reference I can give you is visualize a namespace just like a folders inside your Windows Explorer. But the folder that you see, these are physical separation of files, right? So which under each folder I have different set of files sitting. right? So this is a physical separation of these files. Whereas when you talk about namespace, it's the logical separation of classes. Okay, so .NET is completely built with classes. So the namespace is just a logical separation. In this case, my first .NET program. So that's the namespace. So this is, in other words, logical, because that's not a physical separation, because I'm having that inside a physical file called program.cs. If I go to my folder, that code is actually sitting inside this physical file, this program.cs. Okay, I said logical because I can have another namespace like this. I just copy this, or I can even type this namespace, my namespace. I can have my class inside this. So within the same physical file, I actually have two different namespaces. So that's why a namespace is just a logical grouping of related classes. So that's the line you can answer to anyone. And if you understand what the logical definition means, that's what this is. So it's not a physical separation, but although this is a logical separation, but you can still visualize this namespace is just like a folder structure. So you can visualize this as a folder, and under which you have these classes. Okay, so that's how you use namespace to group a related classes. And when you're referring them, you refer using the namespace. And the best example is here, system. The system is a namespace that's available in this DLL, which is system.dll, right? And similarly, I have other namespaces. Since I haven't added reference to many others, I have system.io. So this is another namespace which comes as part of your system, as well as MS Corlib. Okay, so this is a namespace. A namespace is a logical separation. So now what is the difference between a namespace and an assembly? So assembly, as you see, is a single deployable component, which can be a DLL or an exe. And namespace can span multiple assemblies. So as I have a multiple namespace can be sitting, multiple namespace can I have it in the same file, and also I can have the same namespace in a different assembly also. So it doesn't matter. So the namespace can span across assembly. Whereas since namespace is a logical separation only. Namespace is a logical grouping of classes, and whereas assembly is a physical grouping of logical units. So that's the core difference between a namespace and an assembly. Okay. Again, ILDASM, we just saw what is an ILDASM, so this is good. And I don't want to again walk through this slide, which just stands for intermediate language disassembler. And of course there is another assembler. When it's a disassembler, there is an assembler called ILASM, which is used by the compiler to build the assembly, to bring all your information that you put in as assembly and build this. We'll see more of that in the forthcoming session followed by. Okay, manifest, we did see what is a manifest. It contains the metadata, metadata of the given assembly, which contains the information, security identity, scope of the assembly, resolve references to resources and classes. The assembly manifest can be stored in either a PE file. As I said, PE file is portable executable file, which is a Microsoft standard for standalone PE files. And that is, in other words, is an exe or a DLL. In other words, the PE is a portable executable. But DLL is not executable, but it's need to be consumed by another exe. Okay. Code access security. Code access security will allow the restrict what code can do, and restrict which code can call your code, and identify code. Just for a typical example is file access or memory access. If you are writing a code that needs to have special permissions to access a given memory area, then you need to be your policy need to support, and as well as your compiler need to be aware of. So such things you can convey to the compiler by using respective keywords like an unsafe keyword to write an unsafe code, and also to write the file IO operations. You need to have a specific permissions need to be granted as part of the policy that you want to set up. And that's all about the code access security. We will see a little more of the code access security in the forthcoming sessions. And language interoperability, and this is one of the core functionality or the richness of .NET framework. What are the components that are responsible to deliver the interoperability? Again, what is interoperability? Okay, the question comes here. The answer for what is an interoperability is, if you see our previous slide wherein we have the languages as a topmost in the ladder, wherein C#, VB.NET, or F# and so on. So what happens is, if I write a program in C# and I want to use or consume that in a VB.NET program, I can still do that. So that's called the language interoperability in .NET. So write the code in one language, but you can use it in any other language. So how it is possible? It is possible by using two set of concepts. Number one is a CTS and the other one is CLS. CTS stands for Common Type System and CLS stands for Common Language Specifications. So we'll see what is CTS. In order that two language communicate smoothly, like CLR has CTS, Common Type System. For example, what are the challenges you'll see when you're referring to two different languages? Number one, I'll quickly jump into a program instead of running through the slide. In this case, I'm going to write of course, extend the same program. Okay, adding a variable here. Okay, I'll say instead of a string, I'll say int. I'll say I. Okay, I can even use comma, but I just wanted to keep it separate. I is equal to 10 and I is equal to say 5, and I'm going to write this out using a string. Oops. String.format. Okay. The sum is the sum of just adding a placeholders here is okay. So this is 2, which is I comma j comma I plus j. Okay, so this is what I want to just print out. Okay, there is a semicolon, close brackets. The program compiled successfully. I'm going to run this program to make sure it works. Yes, so I see I just wrote a program in C# using data types called int, and result is sum of it using a simple write line. Okay, so same program I want to write using a VB.NET. Add a simple VB.NET project, new project. I'm going to choose other languages and say Visual Basic. Again, I'll pick the same console application and I'll say VB project. Okay, so just some name. Okay, so in this case, of course, let's not worry too much about the structure, the way it looks like, but all I care is to write the same set of program in the here itself. So how do I do that? In VB.NET, it's a dim I is equal to 10. Dim, oops, there's no semicolon in VB.NET, so okay, j is equal to 5. But of course I can still have my console.writeLine. Console.writeLine, I will say Of course, I did this string dot formats. In the other case here, I can actually do without that. Well, let me try. Sum of I, okay, that is 0, the placeholder, and 1 is 2, and of course I can pass I comma j comma I plus j. Okay, so that's all I need. And console console dot read. So if you see the console dot write line, oops, now console dot write line and read line both are same in the both languages. Okay, except that the way the variables get declared, I'll just make this as a startup project here. Right click and say start a project, and then run this program. Okay, so this is a VB.M project to make sure. So this is a VB project, and the output is 10 plus 5 is 15. Okay, which is good. So my point of interest here is the way the same line of code is written in both the languages. Okay, so if you see, these are the two statements which are identical in both the languages, except the way the variables are declared. In the VB.NET we have a dim I is equal to 10 and j is equal to 5, and here it's just data type and the variable name and the value. Not only that, so when you talk about the more different languages, it could be like int in VB.NET is a 4 bytes of data, which is a numeric data, and it is of course not assigned data. You can have unsigned values as well. In a different language, the whole definition of the int can be different. It could be limited to 2 bytes of data. Its size itself is 2 bytes, and it can be assigned integer and so on. So it can be. So this is a wide definition, wide problem that you have when we talk about language interoperability. So writing a code in VB.NET and making use in a C# is one thing. So to facilitate this, how did what is a common type system that we have? So if I open this output, again I want to have the copy of the respective exes. If I open this code in ILDASM and I see what is the data type it's actually used. Okay, oops, I don't have the latest one here. Let me, oops, because I have all set this to release mode, that's why it's not going there. I quickly change that to debug mode and again do a rebuild solution. Good. Now I should be able to see the changes. Good, I think so. And I'm going to run this again and open the code in ILDASM to see what is the data type that it is actually using. Okay, there you go. I can able to see the changes that I did. Okay, what is the data type that it is assigned? It's actually assigned the system.int32 from MS-corlib. Okay, this is the data type that it is using, system.int32 for both all of my data types. Okay, this is for my 10 and 5 and everything. So that's from my C# program. Okay, I'll keep this aside. And now I'll open the VB.NET code as well, right? Where is VB project, bin, debug, and VB project.exe. And that's the same thing here. Oops, I want to do a side-by-side comparison. Do I have the old window open? Looks like looks like the other window got replaced with this one. So the point here is the type system. So both the languages have the same representation in the intermediate language. So it identified int in C# and integer in VB.NET. Both are represented as system.32. So this is a common type system that makes possible for languages with the different data types talk to each other in the .NET frameworks. So that's the CTS. So the rest of the text is going to talk about that same thing only, so which we saw in demo just now. Okay, so we can skip this part. So this is the same thing that we have seen just now. Integer in VB.NET and int in C#, both refer to int32. Okay, so that's the representation in the intermediate language. Similarly, in their instructions like the if statements, else statements, switch cases, the language specific operations are also represented as using a CLS. So this is all about the intermediate language, in other words. So CTS and CLS are the specifications that one need to know to write a compiler. The CSC is the C# compiler that compiles the C# code to a executable, and it need to be self-aware of the specification of the CLS and the CTS. And just like CTS, CLS also have the rest of specifications for the language. In this case, in the C#.NET, the if and else statement, if you see, the instruction set in MSIL is same for the same line of code in different languages. So that's the CLS stands for. So CLS talks about the intermediate language, in other words. That's a common language specification. So we did see what is a namespace again. The slides are talking about the namespace and the GAC. So we will see continue with the GAC in the following session. I'm going to take a break at this point and see if you have any questions in this first session, and also would like to see any feedback from your end if you want to hear more, or the approach that you want to see in the going forward sessions, and I truly appreciate your feedback from the first session. So we'll see more and more in the forthcoming sessions in much more deep dive into a couple of core elements of .NET. Okay, and let me see if you have any questions at this point.